In this physics flashcards, we'll be talking about relativity, time dilation, and how things act when they move close to the speed of light. Nothing can move faster than the speed of light. More interestingly, the speed of light is relative. This means the speed of light is the same no matter who records how fast the light was moving. Normally, things don't act in such absolute sense. If you are on a train moving 100 miles per hour and you throw a ball 10 miles an hour forward and behind you, you will notice that the ball moves 10 miles an hour. A friend who is not on the train sees you throw the ball and they will measure that the ball goes 110 miles an hour when thrown forward and 90 miles an hour when thrown behind you. If you are on the train moving half the speed of light and you shine a laser in front and behind you, you will record the light moving at the same speed. Your stationary friend on the ground would notice the light moves at the same speed as well, and you and your friend would record the same speed of light. Imagine a special clock. This clock works by shooting a laser at a mirror and recording the time it takes for the light to get reflected. Let's assume the time it takes is 1 second. If the clock moves, the light will still travel in a straight line there and back from the laser to the recorder in 1 second. Now, you stay stationary as the clock moves close to the speed of light. The distance between the laser and the mirror does not change, but the light now has to move up and down and to the side into the direction that the clock is moving. This increases the distance the light needs to travel, so the time it takes for the light to travel now increases. Now, a second passed for the observer on the ground and a second passed with the moving clock are different. So imagine you and a friend have two special clocks. Your friend takes a special clock and starts moving close to the speed of light towards a nearby star and back. As your friend moves towards the star and back, the clock on the spaceship has finished less reflections than your clock. This means less time has passed for the friend on the spaceship compared to you on Earth. This is the basis for general relativity. Some other strange things occur when you approach the speed of light. Time relative to a stationary observer decreases, the lengths of objects decrease as you approach them, and the mass of objects increase as their velocity increases.